Welcome back, smart mathematicians. Let's do question 742. Right, I'll read from here because the information is just the same. Let's read from this statement here. T is a point on F between B and G. This is T. Given that theta is equal to 14,04 degrees and the tangent to F at T is perpendicular to AE. Calculate the coordinates of T. So what do we do here? Right, remember in the previous question in 741, we managed to find that the gradient of AE, MAE, we managed to get that it is 0.25. So now we have the gradient of AE. So if the tangent to F at T is perpendicular to the line AE, then we can find the gradient of that tangent, isn't it? Right. Now calculate the coordinates of T. Calculate the coordinates of T. After finding the gradient of the tangent, then we can find the coordinates of T here. Because the gradient of the tangent is equal to the gradient of the curve at what? At T. Okay, let's just do that. So now we have our line, we have our tangent, which is, this is the tangent, when we are saying it is perpendicular. It is perpendicular to AE there. So we have the gradient of AE. We said gradient of AE is equal to 0.25. To make our life easy, actually we can convert this to a fraction. So which is equal to 25 over 100, which is equal to 1 over 4. Right, so let me write just right here. Gradient of AE is equal to 1 over 4. So if the gradient of AE is 1 over 4, then what is the gradient of the tangent? Remember, if the lines are perpendicular, then their gradients are negative reciprocals of each other. Or if we multiply their gradients, we must get negative 1. So it means the gradient of the tangent is equal to negative 4. You can do this. You can say the gradient of AE times the gradient of the tangent is equal to negative 1. But we have the gradient of AE, which is 1 over 4, times the gradient of the tangent is equal to negative 1. And then we multiply by 4 on both sides of the equation. We find that the gradient of the tangent is equal to negative 4. Okay, well, just knowing that the gradients of the perpendicular lines are negative reciprocals of each other, that is enough. Okay, so now the gradient of this tangent is negative 4, meaning that the curve, the function f, its gradient here at t is equal to negative 4. And then remember that the gradient of the curve is its derivative. So let's derive the function. You remember the equation of the function? What was it? Right, remember our function, we're given f of x is equal to x plus 4, x minus 6. And then we expanded this, we got that f of x is equal to x squared minus 2x minus 24. That's what we did, okay? We did this when we're doing question 7.1, 7.2 there. Remember that? Now let's derive this. So f prime x is equal to 2x. X squared, if you derive x squared, you get 2x minus 2. So this is the derivative of the function. And at t, it is equal to negative 4, the gradient of the tangent. So you can equate this and say 2x minus 2 is equal to negative 4. All right, and then we can transpose negative 2 to the right hand side, becomes positive 2. Then 2x is equal to negative 2. Then divide by 2 on both sides. X is equal to negative 1. So now it means here we know the x coordinate, negative 1. Right, how do we find y? We substitute our x coordinate into the equation. So where there's x, we put negative 1. So what is f of negative 1? It's going to be negative 1 squared minus 2 times negative 1 minus 24. And then we get that this is 1 plus 2 is 3. 3 minus 24 is negative 21. So f of negative 1 is equal to negative 21. Therefore, t, this is negative 21. So it means therefore the coordinates of t will have x coordinate being negative 1 and the y coordinate being negative 21. Okay, right, perfect.